Hello and welcome to Lapping Analytics. My name is Jimmy Lapping. I'm a psychologist and statistician with an interest in a variety of topics that are commonly studied in the health and social sciences. And in this video, I'm going to talk about fuzzy set qualitative comparative analysis. If you are dealing with small sample qualitative and or quantitative data and you are interested in how combinations of observed or coded conditions contribute to an outcome of interest, fuzzy set qualitative comparative analysis is an important method to consider. And to explain how fuzzy set qualitative comparative analysis works, I am going to use an example of a topic that could be studied by social psychologists and other scholars interested in social phenomena, namely a person's decision to leave or not leave a room they are in when all of a sudden at least part of the people present in the room storm out. Suppose that for a new study we are interested in three factors. The first factor of interest will be the group size. For example, because we hypothesize that all else equal, whether someone decides to leave the room when observing that a given proportion of people suddenly storm out will depend on how many other people are present in that room before people start leaving. And in addition to the size of the group, let's say we decide to study if the proportion of people storming out of the room changes the likelihood of someone deciding to leave the room. Although these two factors are logically different entities, they probably do have some influence on someone's decision to leave the room, and their separate and combined impacts on that decision may not be linear at all. For example, in a group of say over 200 people, hardly anyone may leave the room if all of a sudden one person storms out. Same for two or three or a handful of people storming out. However, with increasing numbers of people storming out of that room, most people still present in the room may think something odd is going on, for instance, an emergency or a safety drill, and may decide to leave the room as well, among other things, to find out what is going on. And with the numbers of people storming out of the room increasing, there may be a point when, among people still present in the room, we see a shift from a low likelihood to decide leaving the room to a high likelihood of leaving the room. At some point, you get to that threshold, okay, now enough people leave, now I'm going to leave as well, for example. And last but not least, a person's decision to leave the room when observing that a certain proportion of other people in the room are leaving may to some extent depend on whether at least one of the people storming out of the room are people they know well, or at least to some extent. The idea here is that if at least one of the people storming out is a friend or a well-known colleague, a person may be much more likely to leave the room than when all people storming out are relative strangers. Suppose that for the study at hand we randomly assign 45 people to three possible conditions: a hypothetical group of 10 other people, a hypothetical group of 50 other people, and a hypothetical group of 250 other people. Next, within each of these three size conditions, we randomly assign individual participants to five proportion conditions: 20%, 40%, 60%, 80%, or 100% of the others present suddenly storming out of the room. And finally, within each of the aforementioned 3 by 5 equals 15 combinations of size and proportion, we randomly assign individual participants to three possible proximity conditions. All people storming out of the room are strangers. at least one person in the group storming out is known somewhat, like an acquaintance, or at least one person in the group storming out is a well-known person, like a friend or a long-term colleague. So we have in total 3 by 5 by 3 equals 45 combinations, one for each of the 45 participants. For example, the participant who is in the 10 others group where 20% leave and all are strangers, the question is, suppose you are in a room with 10 other people and all of a sudden two storm out of the room, both of whom are strangers. How likely is it that you would also decide to leave the room? The other participants receive this question framed according to their respective combination of group size, proportion of leavers, and proximity, and each participant is asked to rate individually, without any consultation with others, on the 7 category Likert scale presented here, which varies from very unlikely to very likely. Now, people familiar with this kind of studies might propose to analyze the resulting dataset with linear regression, factorial analysis of variance or analysis of covariance, and report p-values and effect size estimates. However, the dataset is small. Statistical power is limited, especially for simple effects, that is, specific levels of an interaction effect. And the three-way interaction of size by proportion by proximity cannot even be tested because there is only one observation for each three-way combination. That is, we have as many participants as we have size by proportion by proximity combinations, and each combination is presented to exactly one participant. Besides, although regression and other variance-based statistical approaches can handle deviations from linearity, depending on what model is formulated, with the sample size at hand, we do not have enough data to treat the Likert scale outcome as a variable measured at ordinal level, and although it seems it still remains common to treat Likert data as measured at interval level, certainly not everyone will agree with that. And this is where fuzzy set qualitative comparative analysis comes in. On top of the screen you see an article with link that provides a very nice tutorial on how to perform fuzzy set qualitative comparative analysis. This article is available open access. And in the remainder of this video, I use the guidelines of that excellent tutorial on the simulated dataset for the hypothetical study on the decision to leave. I will not discuss all these guidelines and steps followed in this video in order to keep this video short, not make it a very long lecture. But if you have any questions on choices made, well, either you consult the article or you feel free also to leave a comment below the video. I'm happy to answer such questions. So just to summarize the design that we have for this simulated study. We have 3 size conditions, and within each size condition a proportion of others leaving varying from 20 to 100%, and with the information that all people leaving are strangers, or at least one of them is known to some extent or known well. Each of these 3 by 5 by 3 combinations is taken by one participant, and which specific combination is seen by a given participant is determined entirely through random allocation. Suppose that regarding the size of the group, we hypothesize the likelihood of leaving a room to be increasing with the size of the group in the room, and in addition to the group size, the likelihood of leaving a room increases with higher proportions of others leaving the room, and that the likelihood of leaving is also higher when at least one of the people leaving is somewhat or even well known to the participant. And suppose the data we collect looks like this, we see that there are relatively few low ratings, that is, ratings of 1 or 2, which indicate very unlikely and unlikely, respectively, and are depicted in a light pink color here. And there are also only a few ratings of 3 or 4, which indicate either somewhat unlikely or neutral in the case of 4. And in addition, in line with our hypothesis, we see the lowest ratings occur in the small size condition with strangers and also relatively few people, a low percentage of people leaving. But let's use fuzzy set qualitative comparative analysis to get a better understanding of what is going on. Here we have the key questions addressed in our study, and for the proportion of other people leaving the room, we find a consistency of 0.985 and a raw coverage of 0.627. What do these metrics and numbers mean? Well, consistency is about the extent to which a specified rule results in an outcome under study. In this case, the outcome under study is a participant deciding to leave the room. A consistency of 0.985 indicates that in nearly all cases where a high proportion of other people in the room all of a sudden storm out, the participant indicates that probably they would decide to leave the room as well. Next, the raw coverage is the percentage of cases where a participant indicates that most probably they would decide to leave the room, that is captured by that rule. In this case, the rule of a high proportion of other people in the room storming out covers nearly 63% of the outcome, which means that just over 37% of the cases where the outcome is observed, so probably deciding to leave, is not explained by this rule. And of course, in addition to the proportion of leavers, we have the degree of proximity, which in this study receives very similar consistency and coverage values. Also very similar consistency and coverage values are found for group size. However, using the fuzzy set qualitative comparative analysis software proposed by the authors in the tutorial article that I referred to earlier, with all the coding settings that they propose, this third factor does not have any added value in the presence of the other two factors. That is, a solution in which the proportion of levers and the degree of proximity are the two factors contributing to the outcome under study has a consistency of 0.952 and a coverage of 0.872. Consistency values over zero point 0.8 are generally considered okay, and values closer to 1 indicate that there are fewer exceptions to the proposed solution in terms of the occurrence of the outcome under study. Now, which is to say that in nearly all cases where this rule is the case, this rule applies, the outcome is observed. And for coverage, the proposed solution is supposed to work for at least 75% of the cases, hence values starting 0.75 are usually considered okay. In this case, the solution coverage of 0.872 indicates that the proposed solution covers just over 87% of the cases where the outcome under study was observed, which is to say that there's about 13% of the cases where the outcome was observed which are not covered by this solution. There were other factors at play. Now, is this the only way to look at the data? The answer to this question is no. The way factors are coded to some extent influences the consistency and coverage outcomes. And moreover, different ways of coding can help to look at the same findings from different angles. One alternative coding that can be found in decomposing the size factor into dummies, that is 0, 1 codes for two of the three conditions. Here the size 50 and size 250, for example. And doing so, we find the solution that you see here. For levers, the consistency and raw coverage are as in the previous solution, but now we get a somewhat different perspective on the role of size and proximity. Basically, this solution indicates that someone is likely or very likely to decide to leave the room if many others are leaving, or in groups of 50 or 250, at least one of the people leaving the group is well known by the participant. With this solution, we achieve a slightly higher consistency while the coverage goes down a bit, yet still remains just over 0.8. Now let's have a look at another alternative way of coding. In this case, we instead of using dummy coding for the size factor, we apply dummy coding, that is 0, 1 coding, to the proximity factor. Um, and doing so, we find that someone is likely or very likely to decide to leave the room if many others are leaving, or if at least one of the people leaving the room is well known to the participant, or in a more sizable group, at least one of the people leaving is known to some extent. For this solution, we find a similar consistency but a clearly higher coverage. Next, what happens if we dummy code both the size and the proximity factor? Well, we find that someone is likely or very likely to decide to leave the room if many others are leaving, or if at least one of the people leaving the room is well known to the participant, or in a group of 250 others, at least one of the people leaving is known to some extent. So this solution is very similar to the previous one, both in terms of interpretation and in terms of consistency and coverage. Now, finally, although there are several other ways of coding, let's look at one more alternative, this time in which we dummy code all three factors. This solution also demonstrates good consistency and coverage and basically indicates that someone is likely or very likely to decide to leave the room if either A, at least 80% of the others in the room are leaving, B, at least one of the people leaving is well known to the participant, C, in a group of 10 or 250 people, at least 60% are leaving, D, in a group of 250 people, at least one of the people leaving is known to some extent to the participant, E, if 60% are leaving, at least one of them is known to some extent by the participant, or F, in a group of 50 people, 40% are leaving and at least one of them is known to some extent by the participant. In sum, although these different solutions arising from different coding ways lead to slightly different interpretations of what is going on, it is clear that a high percentage of others in the room suddenly storming out, and or regardless of the proportion of leavers, someone leaving being well known by the participant are key predictors of a participant probably deciding to leave the room. And in addition, the group size factor may not in itself be decisive, but in interplay with the other two factors, it can help to explain leaving decisions to some extent. Well, and that's it. I hope you find this tutorial video on fuzzy set qualitative comparative analysis useful. If you have any questions or suggestions, as I already mentioned, just leave a comment below the video. And on my channel you will find plenty more videos related to methods for qualitative, quantitative and mixed methods research. Having said, thank you for watching. Thank you for listening, and I hope to see you back on this channel soon.